Okay, so we know here, let me go ahead and rewrite it. X to the fourth minus x to the third plus x squared minus 3x minus 6. Or you can make that 1x to the fourth. Our lead coefficient, a sub n, is equal to 1. And our constant coefficient, a sub 0, is equal to negative 6. So those are the only two you're worried about. Okay, and that's where we go into our possible rational zeros. Remember, that's the factors of a sub 0 divided by the factors of a sub n. Always remember that on, and you'll have the right order. Okay, so really you have the factors of negative 6. Okay, which means you can factor out positive or negative 1. You can factor out positive or negative 2. You can factor out positive or negative 3. And you can factor out positive or negative 6. Any of those will be factors of negative 6. Divided by your factors of your lead coefficient of 1, which is just positive or negative 1. Okay. So since you have positive or negative 1 down here, it doesn't change anything up there. So really, it's just positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6 for your possible factors. Okay. So now once we have those, we're going to use synthetic division and test each one. Okay. So let's use synthetic division to test each one. All right, so let's say if we try k equals negative 1. Remember, we have to try positive and negative 1, positive and negative 2, well, wrong one. Positive and negative 3, and positive and negative 6. Okay, so if we try k equals negative 1, remember that's just negative 1. And then you get all of your coefficients and put them there. So you have 1, negative 1, 1, negative 3, and negative 6. Okay, so just like before, bring down the 1. Oh, bring that up some. Negative 1 times 1 is negative 1. Then we add them together. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is positive 2. Go ahead and add those together. 1 plus 2 is 3. Negative 1 times 3 is negative 3. Go ahead and add those together. Forgot to add those together, it'd be negative 6. Negative 1 times negative 6 is positive 6. So if we go ahead and add those together, we equal 0. So in this case, our remainder is equal to 0. So we know that negative 1 is a 0 of our function. Okay. Now, how we're going to use that to make it a little bit simpler is we know that this function is a fourth degree polynomial, which means if we're going to factor it, f of x has to equal x minus some number times x minus some number times x minus some number times x minus some number. Okay, remember, that's a fourth degree polynomial, which means at some point it can be factored out, either using real numbers, complex numbers, or a combination of both. But we know it's a fourth degree polynomial. It can be factored into four factors. Okay, and we know one of those factors just happens to be -1. Okay, so that means that is -1. Okay, so that means we end up with f of x equals x minus some unknown times x minus some unknown times x minus some unknown times x minus -1. Okay. Or you can just write it as x plus 1. Well, actually, we still have one more step to go before we write that. Okay, so this is just x plus 1. But now this is where we use what's up here. Because remember, this was our x to the fourth, our x to the third, our x squared, our x, and our constant. And remember, whenever we come up with a 0 as our remainder, all of those exponents drop 1. So instead of x to the fourth here, this would become x to the third, x squared, x, and this is our constant. So now we turned a fourth degree polynomial, we made a factor of x minus 1 and turned that into a third degree polynomial. So now, this is the part that I'm getting kind of geeky. This is really cool to me, but you have this third degree polynomial, so you have x to the third minus 2x squared plus 3x minus 6 times your x plus 1. Where this is basically just that part. Okay. So now all you have to do is factor your third degree polynomial. We have this one already. So now we just have to factor this out. And we're going to do that using the same process. So we're going to continue that on the next page. I'll leave that up there for a second. Let me write down where we left off. So f of x equals x to the third minus 2x squared plus 3x minus 6 times x plus 1. All right, so picking up right where we left off, we already tried k equals -1. Okay, so now we're going to try k equals 1. But we're not trying to factor the whole thing we did before. Now we're just trying to factor that one. Because you already picked one. Once you get an r equals 0, you're no longer using the same one. Now you want to factor this part of it. Okay, so we're using trying k equals 1. Again, we put 1 on the outside. And we get all of our, I guess you can call them new coefficients. And we're going to use those now. Okay, so you have 1, -2, 3, and -6. So each time you get an r equals 0, it gets a little bit simpler and a little bit simpler. So now, just like before, we bring down the 1. 1 times 1 is 1. Go ahead and add those together. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Go ahead and add those together. 3 plus negative 1 is 2. 1 times 2 is 2. Add those together. Oh, we know that it's not 0. Okay, so we know that 1 is not a 0. Now, whenever you get a remainder that's not 0, then you just reuse the same 1. You only change it when you get a remainder that's equal to 0. Okay, so let's say if we try, I'll kind of separate that a little bit. Well, let me put here that 1 is not a rational 0. I guess you could say a 0 of f of x. Okay, so we know already that if we plug 1 into our original equation, our original function, we wouldn't get 0. But if we plugged in negative 1, we would get 0. Okay, let's try k equals 2. Since that was one of our possibilities. So we put 2 right on the outside, and we use the same 1 since we didn't end up with an r equals 0 here. So you have 1, negative 2, 3, and negative 6. Okay, so now we test this one. Bring down our 1. 2 times 1 is 2. Add them together. Negative 2 and 2 is 0. 2 times 0 is 0. Add them together. 3 plus 0 is 3. 2 times 3 is 6. Add them together. Negative 6 and 6 is 0. So here we know that our remainder equals 0. So that means that 2 is a 0 of our f of x. Okay. So just like before, we know this is x to the third, negative 2x squared, plus 3x minus 6. So we have our x to the third. This is our x squared term. This is our x. And this is our constant. So once we have an r equals 0, all of those exponents drop 1. So instead of x to the third, this becomes our x squared. Let me make that 2 a little bit clearer. Okay, so that's x squared. This becomes x. And this becomes our constant. Okay. So that means that f of x equals x to the third minus 2x squared plus 3x minus 6 times x plus 1. We know that, earn that, 2 is a 0. So that means that f of x is equal to x squared times 0x, or 0 times x, which is just 0, so you can leave that out if you want to, but I'll put it in just to hold the place, plus 3 times, remember, x minus 2 times x plus 1. Okay, so we know since that's a 0, if we plug in 2, that would be 2 minus 2, which is 0, and the whole thing would equal 0. Same thing with negative 1. If we plugged in negative 1, it would equal 0, so the whole thing would equal 0. So now, once you get to an x squared, you can keep using synthetic division, or you can just factor it using the quadratic formula or whichever method you want to. The whole, not the whole goal, but the, I guess you could say, first goal is to get it down to x squared. Okay, so let me just simplify that a little bit. F of x equals x squared plus 3 times x minus 2 times x plus 1. Okay. So again, once you get it down to x squared, it's pretty easy to find the 0 for that. So this just tells us that x squared plus 3 can equal 0. X minus 2 can equal 0, which you don't have to do those two since we solved them already, but I'll go through the steps. And x plus 1 can equal 0. You make any of those 0, it'll make that whole thing 0, and that's where it crosses the x-axis. So if we subtract 3, x squared equals negative 3. Square root both sides, so we know that x is equal to plus or minus square root of negative 3. Or you can just make that, bring that up a little bit. X equals plus or minus square root of 3i. If you remember your complex equation, because remember, wherever you have a negative square root, the negative just comes out to be I. If you remember that, I equals square root of negative 1. Okay, so we already know if we add 2 here, that x is equals 2, or x can equal negative 1. Like I said, we didn't have to do those two because we already figured out earlier that 2 and negative 1 were zeros. Okay, so that means if we wanted to factor this out, we can make f of x equals x plus square root of 3i, x minus square root of 3i. X minus 2, and x plus 1. And if you FOIL those two, you just end up with x squared plus 3. Okay, so we know at all of those values, these are all your zeros. All right, any questions on that one? All right, so I'll leave that up for a little bit. Like everyone's done right. All right. Okay, so let's say, for example, we wanted to know what are the actual rational zeros of f of x equals x to the third plus 3x squared minus 25x plus 21. Okay, so we can tell just before we start that our lead coefficient is equal to 1, and our constant coefficient is equal to 21. Okay, so that means our possible rational zeros remember, that's the factors of our constant coefficient divided by the factors of our lead coefficient. Okay, remember, Think of ON and you'll never mix those up. Okay, so that's going to equal factors of 21 over factors of 1. Okay, which if we equal that at 21, it could be positive or negative 1. Both of those go into 21. Positive or negative 3. We'll clean that up a little bit. Both of those can go into 21. Positive or negative 7. They can go into 21. And positive or negative 21. All over, the factors of 1 is just positive or negative 1. And whenever you have that positive or negative 1 down there, you can just get rid of it. So you have positive or negative 1, positive or negative 3, positive or negative 7, positive or negative 21. Okay. These are all your possible factors. I mean possible zeros. Sorry about that. Okay. So just like before, we just pick one and start. So let's start with k equals 1. If you wanted to, you could start with k equals 3. You could start with k equals 7. Doesn't matter which one you start with. If you just have a really good feeling about one, you can start with that one. Okay. Okay, so we start with k equals 1. So we use our synthetic division, and we plug in our coefficients. So that would be 1, 3, negative 25, and 21. 3, negative 25, and 21. Okay, so just like before, we bring down our first one. 1 times 1 is 1. We add those two together. We get 4. 1 times 4 is 4. We add those two together. We get negative 21. 1 times negative 21 is negative 21. Add those two together, and we got lucky, because our remainder is equal to 0. Okay. So remember, whenever your remainder is equal to 0, you have your x to the third plus 3x squared minus 25x plus your constant. They all drop down 1. So this x to the third becomes x squared. This becomes x, and this becomes your constant. Okay. Now the one thing we know that f of x equals x to the third plus 3x squared minus 25x plus 21 is a third degree polynomial. Okay, so the fact that it's a third degree polynomial means that at some point you can have f of x equals x minus some value, x minus some value, and x minus some value. Okay. We know that 1 is a 0, so we can just plug 1 into one of those question marks and replace the others with this one. Okay, so we have x squared plus 4x minus 21 times x minus 1. Yep, so that's our f of x. So we were able to replace all those question marks. Okay. Now, if you wanted to, you could go ahead and do the synthetic division again, or you can just factor that out. So we find two numbers that multiplied equal negative 21 and add to equal positive 4. That would be positive 7 and negative 3. So this is just x plus 7 times x minus 3 times x minus 1. So sometimes if you get lucky on the very first one, then all you have to do is factor it whichever way you want to. Okay, so that means our f of x is equal to x plus 7 times x minus 3 times x minus 1. Okay, so that means x plus 7 can equal 0, or x minus 3 can equal 0, or x minus 1 can equal 0. Okay, so x plus 7 equals 0, x minus 3 equals 0, x minus 1 can equal 0. Okay, so in other words, x, yes?
Where did x minus 1 come from?
Oh, that was when we started with x minus 1, and we ended up with a remainder of 0, then we knew one of those question marks would go there.
But we solved it through like it was 1. We didn't solve it through like it was minus 1.
Yep, but it's always going to be x minus whatever that 0 is, because if we plugged in 1, it would be 1 minus 1, and that would make that 0, and it would wipe out the whole thing. So you want to find out all the values that will make your f of x equal 0. And it just so happens we got lucky and 1 was one of them. Yeah?
So if you happen to put in 7 or 3, you would also be able to find, like...
Yep, so if you plugged in negative 7 in your original equation, it would equal 0. If you plugged in positive 3, it would equal 0. All we did was factor it out first to find those values. Okay, so we know that x equals negative 7. Oh,